Divargo, I will try your problem, but as far as I recall, square, it should have 31 square elements. Okay, I can't recall the exact formula to compute it, but I think it should be. I think if you uh, quotient this by this, okay, where a plus ib is reducible, this should have a square plus b square element as far as I remember, but I will have to check. Okay, this field should have a square plus b square element. I think we did till 5, na? Yes. No. Yeah, till 4 we did, I think. Okay. So how should we approach 5? T be the diagonalizable linear operator on R cube.
Tada screen share.
Oh, sorry. So how should we do 5? T diagonalizable linear operator on R cube, which we discussed in example 3 of section 6.2. Use Lagrange's polynomial to write the representing matrix A in the form so how to do it? So first let's see what is T. Section 6.2, long way back. So this was T, right? So this is my T. So this is my T. And this is the so one thing is clear now. I think we can write D as twice 0 0 0 0 1 0 0 0 1, right? So suppose this is E1 prime and this is E2 prime. Okay. So clearly E1 prime square is E1 prime and E2 prime square is E2 prime. Okay. So these are projections. And is this, and also E1 prime plus E2 prime is identity. What is E1 prime, E2 prime? What is it? Is it 0 0 0? This is 0 0 0, isn't it? So you have managed to write D in this way, like E1 prime plus E2 prime and so on. Okay. And you know the matrices P, we know the matrices P such that P inverse AP is D, that is A is PDP inverse, right? So if you do PDP inverse, what do you get? P E1 prime P inverse plus P E2 prime P inverse. So A is, sorry, this is twice E2. So this is E1 and this is E2. You can multiply this to check the criteria. So E1 plus 2E2, check that. E1 square is E1, E2 square is E2. Okay. You know what is P now? P is done by this. I mean, P was done by, we compute P by, yeah, we compute P by alpha 1, alpha 2 and alpha 3, right? Isn't it? This was our change of basis matrix, na? So alpha 1 is 3 minus 1, 3. So alpha 2 is what? 210. And alpha 3 is what? So you can obtain P by this, na? We obtain P from this. Okay. So this is how we do. Shubrita, can we use Lagrange's polynomial to compute the same?
হ্যাঁ সেটাই ভাবছিলাম।
Okay, how?
ওই দাঁড়াও, ওই সেকশনটায় নিয়ে যাও একবার 6.2 তে।
আবার
হ্যাঁ এক্সাম্পল 3 মনে হয় দেখছি।
6.2.
ও আচ্ছা ওটা তো ইয়ে দাঁড়াও দাঁড়াও, হ্যাঁ এখানে C1 আর C2 তো
1 আর 2.
যেটা 1 আর 2, তাহলে P1 আর P2।
Correct.
P1 তো minus of x minus 2।
Yes. So this was one way to do it. And wait a minute. We have seen a result, I think. Just a minute. I'm looking for it. Yes, this PJT is EJ, na? We will use this. Where PJs are Lagrange's polynomial, PJT is EJ. We will use this. So alternative method is we know that P1T is E1 and P2T is E2, right? Where what is P1? P1 is x minus 2 by 1 minus 2, right? And P2 is x minus 1 by 2 minus 1, right, Shubrita?
হ্যাঁ
Okay, so you can compute just this. Okay, it follows from
তাহলে 2 লাইনে হয়ে যাচ্ছে
follows from what? Mm, follows from page 217. Okay, what about 6? A be the 4 cross 4 matrix. Just do the same way. Okay, just do the same way. You can figure out the eigenvalues and then just do the rest. Just a minute. আমি পড়ানো কি আর্জেন্ট কিছু আগে না কি হয়েছে বলি ও যাচ্ছিস মানে করতে কি হবে বাহ ওই দক্ষিণেশ্বরের অটোগুলো পিছন দিক থেকে তো খুবই ভালো হয়েছে ঠিক আছে ঠিক আছে ক্লাসটা করি Okay, so you can do it the same way. Okay, so you can do 6 same way, just like we did 5, same as 5. What about 7? In exercise 5 and 6, for each I, the space of characteristic vectors associated with the characteristic value Ci is spanned by the column vectors of the various matrices Ei. Is that a coincidence? In the space of characteristic vectors associated with the eigenvalue Ci, that is, this is nothing but kernel t minus cii Okay, so what was t? T was c1 e1 c2 e2 and all that. So t is c1 e1 plus ck ek, right? So c1 e1 up to ck ek minus ci I, what is it? Write I as, I want to say this. So T is summation C Cj Ej. Okay. So T minus Cii and I is summation Ej. So this is nothing but summation Cj Ej minus Ci summation Ej. So this is, so the ith term is going to cancel out. The ith term is going to cancel out and we are going to have Cj minus 1 Ej, j not equal to I. Shurita, is it true? Is it correct? No, it is going to be Cj minus Ci, no? Right? Yes. Yeah, so it is true. We have really got it, I think, right? So this is now. So if, what does it imply? If V belongs to car T minus Cii then V belongs to range, yeah, look at this, EJ. I mean, what should I say? Like this. Direct sum of range EJ, J not equal to I. That's what we have here, no? Because if you put a V here and put it 0 there, since V belongs to kernel here, get 0 here, 0 here, and what do you get? That CI, yes, so I mean just this. Okay, what about 8?
দাদা,
বলো।
ওই যে কোনো সাবস্পেসের জন্য আর একটা সাবস্পেস পাওয়া যায় না, যেটা ডিরেক্ট সাম ওই ভি হবে? ডাব্লিউ যদি ধরে নিই, তাহলে ডাব্লিউ ড্যাশ বলে আর একটা পাওয়া যায় না, যেটা মানে
Okay, that's
একটা
a good
সাবস্পেস এরকম
question.
একটা রেজাল্ট,
That's a
এরকম
good
একটা প্রুফ
question. That's
করেছিলাম।
for, does there exist for every W a subspace which is also T
এরকম প্রুফ
invariant, right?
করছিলাম কিনা জিজ্ঞাসা করছি,
You are asking
যেন
that?
কোথাও একটা দেখেছি।
Okay. Can you find out it? Find it out.
এই বইটাতেই হয়তো দেখেছি।
Yes. Probably in chapter 6. Just look at it.
হ্যাঁ,
See if you can find it out. So she is asking that if W is a T invariant subspace, does there exist another T invariant subspace W prime such that W direct sum W prime is V? সুব্রিতা, পেলি?
জি। এক্সারসাইজে ছিল দাদা।
কোথায়?
ওই চ্যাপ্টারটারই একদম প্রথম এক্সারসাইজটা, 1 নম্বর যেটা।
6.6 or 6.7? Hmm? No, no, you were asked. Were you saying this? I thought you were asking something else.
এটা হলেও তো হয়ে যাবে।
Why?
দাঁড়াও। তুমি যেভাবে ভাবছিলে সেভাবেই করো, আমার মনে হয়।
Hmm.
দুটো প্রজেকশন যদি ধরে নিই,
Hmm.
তাহলে একটার রেঞ্জ অফ ইআই তো ডাব্লিউআই হবে,
Hmm.
মানে E1 আর E2 যদি দুটো প্রজেকশন ধরে নিই, মানে দুটোই ইনভ্যারিয়েন্ট ই এর আন্ডারে।
What are you saying? I mean, you are saying about 8, right?
হ্যাঁ, হ্যাঁ।
Okay. So you are saying I have done it in some method. So given that TE is ET for all E such that E square is E, right? Right? Okay. So let T in the standard basis is this matrix. Okay. This is the matrix of A in the standard basis. Okay. And suppose Eij is the matrix where 0 everywhere and 1 in the ijth place. Okay. So E11 square is E11, right? So we have TE11 is E11T, right? So this will imply A1I is equal to AI1 for all I. Once you do this multiplication, take this, multiply this with, from this actually, call this A. AE11 is E11A. This will imply this, okay? The same thing, and if you do E22A, this will imply A2I is AI2 for all I, okay? Or maybe I should write it like, forget it, let's write it. Write A first, A11 up to ANN. So what is this? This matrix is nothing but the first column and 0 everywhere else, and this matrix is nothing but the first column, the first row, and 0 everywhere else, right? And from here you have A1I is AI1, right? Similarly, if you do like this, EJJ with EJJA, you will be having AJI equals to AIJ, right? But you look at here, okay, look here. This entry is A12 and this is equal to A21, which is 0. So you realize that every element Aij is 0 if I not equal to j. You realize that with this and this, by this matrix equation and this, we can imply this Aij is 0 for I not equal to j. Okay, is that okay? Because suppose A12 is here, so this has to be 0 because there is a 0 here. So A12 is equals to A21, so that is also 0. So in this way you will see that Aij is 0 if I not equal to j. So A matrix looks like this, A11 up to ANN. Okay. Now there is another thing. Now assume another basis, beta prime, to be E1 plus E2 and En, where beta was E1 to En. Okay, this is our basis. define E to be the projection on this subspace, I mean generated by E1 plus E2, the first component of this. Okay, so this is a projection, so A commutes with this as well, so TE is ET. This implies TE E1 plus E2 is E T E1 plus E2, right? What is T E1 plus E2? T E1 plus T E2 is nothing but A11 E1 plus A22 E2. And with this, I mean, in this line, E of E1 plus E2 is E1 plus E2, na? Because E is a projection on that side. So it is TE1 plus TE2, right? So that is again A11 E1 plus A22 E2. So where does this? What should we do next? Just a minute. I'm a bit. Okay. So what is so what is E of E1? What is it? This is nothing but this minus this, right? This is, but this is 0 na, because E is the projection on this, the vector, the first vector. So this is E1 plus E2 and this is 0. So this is A11 E of E1, which is E1 plus E2, and this part is 0, right? From here you obtain that A22 is A11. So similarly you will get A11 is AII for all I. So A is basically a scalar multiple of the identity. Understood? Okay. So what about problem number 9?
দাদা
Hmm.
দাদা, হুম,
Hmm. হ্যাঁ বল।
মানে আমি না একটা রেজাল্ট ওটা কাজে লাগাবো কিনা সেটাই জিজ্ঞাসা করছিলাম।
কি?
আমি পরে তোমাকে জিজ্ঞাসা
আচ্ছা,
করছি। পরের চ্যাপ্টারেই আছে ওটা মনে হয়, একটা করোলারি আছে 220 পেজে।
হুম,
220 বা 221-এ এই এই সাথে রিলেটেড মনে হয়। ঠিক আছে।
what about 9? So 9 says vector space of all continuous straight valued function on the interval and even and odd functions given. They say that show that v is a sum of this and t is an indefinite integral. Are these to t invariant? Okay, so I will give you 3 to 4 minutes to try it. Then let's see whether we can solve it or not. Okay, so let's try to do 9. So one thing is obvious, I mean, we can write fx to be half fx plus f of minus x and half fx, right? So this is, say, gx and this is hx. This is even and this is odd. So this is true, right? And if fx is f of minus x, which is again equals to minus fx, then this implies fx is 0. So this is true, like v is w naught, I mean we direct sum wo, this is true. That's v is the direct sum of even and odd function, this is true. Okay. What is it? t is the indefinite integral. Okay.
দুটোই ইনভ্যারিয়েন্ট হচ্ছে না,
Hmm.
তাই তো দাঁড়াচ্ছে।
Yes, because if you integrate 0 to x t square, you get x cubed by 3. This is even but this is odd now. And again it's the same thing. If you integrate t cube, you get x to the power 4 by 4. So it's the opposite. I mean, integrating this, you going into this space. Integrating this, you are going into this space. Okay. So none of them are t invariant. T sends one to the other. Okay. So let's move on to primary decomposition theorem. How long is the proof? No, not much. Okay, I will give you 2 minutes to read this discussion. Here it is. Just this discussion.
দাদা এই করোলারিটা কথাটা বলছিলাম।
Okay, but this is in the next section, na? If we do module theory, if I get time to do module theory, I will do it over PID, finitely generated abelian groups. Okay, so I will request you guys to go through this page 220, and we are trying to something till this, before this theorem. You have 2 to 3 minutes. Please read the discussion. See, this is the goal of this whole chapter, to prove this theorem. The previous 7 sections, they lead to this theorem, primary decomposition theorem. Let T be a linear operator on a finite dimensional vector space V over the field F. Let P be the minimal polynomial for T. P is P1 to the power R1 up to Pk to the power Rk, where Pi's are distinct irreducible monic polynomial over F and Ri are positive integers. Let Wi be the null space of Pi T to the power Ri. Are positive integers. Then V is W1 directs from W2 up to Wk. Each Wi is invariant under T. If Ti's are operators induced on Wi by T, that is Ti is T restricted to Wi, then the minimal polynomial T of Ti is P to I to the power Ri. Okay. I think statement of this proof is enough, but okay, let's go through the proof anyway. If the direction decomposition of 1 is valid, how can we get hold of the projection E1 to Ek associated with the primary decomposition? Okay. So we are trying to find out Ei such that range Ei is Wi. Ei is our projection. The projection Ei will be identity on Wi and 0 on other Wj. We shall find a polynomial Hi such that Hit is the identity on Wi and is 0 on the other Wj, so that H1t plus 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 Hkt is identity. Okay, let's see what they are doing. So they have said that define Pi to be P by this. Okay. Now observe that these are relatively prime, right? Since they are relatively prime, there are GIs such that summation Fi Gi is 1. This is because Kx is a PID. Note also that I not equal to j, then Fi Fj is divisible by the polynomial P, right? This is true. Fi Fj is divisible by P. We shall show that the polynomial Hi is equal to Fi Gi. Okay. Let Ei is Hit. Okay. Fit into Git. Since summation H1 to Ht is 1 and P divides Hi, this is true. This is true, na? Because Ei, Ej is nothing but Fit, Git, Fjt, Ggt. So Fi Fj is divisible by P. So these are 0. Thus Ei's are projections which correspond to the direct sum decomposition of the space V. We wish to show that range of Ei is exactly the subspace Wi. It is clear that each vector in the range of Ei is in Wi. True. For if alpha is in range Wi, then range Ei, then Ei alpha is alpha. So Pi T alpha, Ei T to the power Ri alpha is Pi T to the power Ri Ei alpha. Put the value of Ei there and get 0. So alpha is in the kernel of this, which is Wi. Because Pi to the power Ri Fij is divisible by the polynomial P. Conversely, suppose alpha is in the null space of this, then Fij is divisible by P to the power Ri. In the null space of this, so Fij, what was Fi? What was Fi by the way? Fi was this, okay? And so Fjt Ej alpha is 0. Then Fj Gj is divisible by Pi to the power Ri, and so Fjt Gjt, where it is, that is Ej alpha is 0 for j not equal to I. But then it is immediate that Ei alpha is, yeah. So it is true. See, today is almost 11:45. We will start with this corollary in the next class, okay? We will start with this corollary. So that's it for today.